Here is a fun cross-linking demonstration. This material is a two-part polyurethane foam. So you mix equal parts together and we have a cross-linked chemical polymer that results. Okay, so I've already added the first part with some food coloring in this little cup. Now I'm going to add the second part. It takes a few minutes for this to happen, so we will talk about cross-linking a little bit more. Here we go. We're going to add the second part. We have to stir it up very, very, very well. Alrighty, we'll let that sit right there for now. Hopefully you can see it. So we've been talking a little bit in other videos about chemical reactions and things that you can see as an evidence of a chemical reaction. In this case, one of the things that we will look for is something that's producing a gas. So I'm thinking that this red substance is actually producing a gas, and that is the proof that there is a chemical reaction taking place. So here you have it, the finished product. Still a little bit tacky, but it should solidify a little bit better. So this material will expand to about 30 times its original volume. That is a cross-linked polyurethane foam. It got warm as well. So there's another type of thing that we can talk about, exothermic reactions. We have one more cross-linking demonstration, and let me get that ready for you right now. These are two products that you can buy at the grocery store, or you can get them online as well, that you can use to cross-link a polymer. The Elmer's glue is the polymer, polyvinyl alcohol, and the borax, sodium tetraborate, is the cross-linking solution. So in the white cup, I have some of the Elmer's glue. It's yellow because I just added food coloring to it. And in this cup, I have some of the borax solution. So I dissolved it in water to make it easier to mix. We're just going to add a little bit of that to our glue. And we're going to stir it up. We can use our finger to stir it. And notice what happens. We'll stir a little bit more. So here we are. We're not really making slime. We are cross-linking a polymer. All right. So the more we work it, the more stretchy it's going to be. Cross-linked polymer putty, not slime. CLPP is what we call it. I need a little bit more. We're going to mix it up in our hands. Now this is what we call a non-Newtonian fluid. Okay, so it doesn't behave as normal fluids do. Under certain conditions, it acts more like a solid than a fluid. All right, and this material has what we call strain rate dependence. And what that means is that the amount of strain is it will change according to the amount of strain that you put on it. So it's the rate. So if I'm straining it at a very slow rate, it's going to stretch and flow like a fluid. However, if I increase that rate of strain, it's going to change the way that it changes. So if I pull it quickly, it's going to break, and it acts more like a solid than a liquid. Cross-linked polymer putty, fun stuff. Keep it off of your clothes, keep it off of the furniture, keep it off your pets, keep it off your carpets, and don't do this. Okay, because you don't want to do that. Only I can do that. Have a great day, everybody. Stay safe out there, and go Zips.